All right, welcome. Today's lesson is going to be about exponent rules, and we're going to be doing this over the next few days. Today we're going to start with zero exponents. So to figure out what the heck does 3 to the 0 power evaluate to, and then negative exponents, like how about 3 to the negative second power? What does that evaluate to? And then we're going to do a multiply rule where you have x squared times x cubed, and what does that simplify to? Okay, so most of the questions are going to be to simplify. I shouldn't have said evaluate there, but to simplify with exponent rules. Okay, so just before we get too far, some kind of basic vocab you might want to jot down here, taking notes, is that the big number here is called the base, and then the little number up top is called the exponent. Sometimes it's called the power, or I don't like index here, to be honest, but I would usually just call it like an exponent or a power. All right, and then what it really means when you have x to the fifth, that really means x times x times x times x times x. So you have 5 times x's. That's really what it means, right? This one here would mean an 8 times an 8, so it evaluates to 64. Okay, so that's just some review for you about exponents. Okay, so one of the things that I think is really can be tricky about exponents is they apply to only what's the immediate left. So if you want to jot down a couple examples of here, like the difference between these first two is on the second one here, if we expanded it, it would look just like that. Okay, and the cube is only for the x. The square is not being cubed. It's kind of just, the 2 is not being cubed. It's just kind of on its own. Okay, versus here with parentheses, now this 3 sort of applies to both of them. And so what it means is you have that little parenthesis 3 times. So you have a 2x times 2x times 2x. So you can see the difference here is on the second one you only had 2 once. Now you have 2 3 times. So you sort of end up with the 2 cubed and the x cubed, right? Which means if you do 2 times 2 times 2, you get 8. So this top one cleans up to 8x cubed, right? And then this is also true with negative. So on this second example, we've got to treat the negative 2 as the negative part is actually separate from the 2. So sometimes I even write it like negative 1 and 2 separated. So what happens on this first one, if you type it in your calculator, you'll get 4. And the reason is it's negative 2 times negative 2, and that's 4, right? This square applies to both the 2 part and the negative. On the second one, what happens there, I know this is super weird and super in the weeds here, but the square is only for the 2, not for the negative. So I kind of think of it like I wrote down here. So this is really like negative 1 times 2 times 2. So that actually evaluates to negative 4, right? And that is super confusing. But yeah, I guess kind of an important aspect of exponents. Okay, so that's kind of review stuff. So next we're going to do 0 and negative exponents. And so what happens here is there's sort of a pattern. So I'm just going to take 2 cubed is 8, 2 times 2 times 2. Okay, and then 2 squared is 4, 2 times 2. 2 to the first is just a single 2, and that's just 2. Okay, so to figure out 2 to the 0, we're just going to continue this pattern. Okay, so basically, if I keep going here, you can see the pattern is we are dividing by 2. Okay, so what happens, right? We divide by 2, divide by 2. So if we want to do 2 to the 0, you actually divide by 2 here, and you get 1. Okay, so oftentimes kids will think something to the 0 power is going to be 0, but it's actually 1. Okay, and if we continue this pattern, this will actually help us with negative exponents too, because 2 to the negative first is not negative 2 or something like that. We just got to keep doing our divide 2 pattern so that if we do 1 divided by 2, we get 1/2 here. Okay, so 2 to the negative 1 power is 1/2, and then if you just keep going again, divide by 2 again, so 2 to the negative 2 power is 1/4. You just divide that by 2. Okay, so it's kind of weird, but I guess something for the notes, if you want to write here, you can write anything, any base to the 0 power is always 1. And you'd think it'd be 0, but it's actually 1. So this is kind of my best attempt to explain that. So here's your 0 exponent rule. Okay, and then if you want to do one for negative exponents, so this one's mostly going to be about negative exponents. If you want to write down some examples of what they are, hopefully this will help you. Okay, so back here we said 2 to the negative 2 is 1/4. And so the way to sort of figure them out is like if we take 2 to the negative 2, what you actually do is sort of flip it. So if we think of this as a fraction, we kind of flip it and then it becomes positive. Okay, so we end up 2 to the negative 2 really means do 1 over 2 squared. All right, and that comes out to be 1/4. Okay, so if we look at another example, like maybe I'll do one with x. If we're doing x to the negative 5, what we really do here is sort of flip it, and it ends up being 1 over x to the 5th. That's what a negative exponent means, do is flip. Okay, and so there's a couple other situations where this kind of comes up. So like if if the negative exponent started in the denominator, let's say it was x to the minus 3, then I kind of think of it as like moving. Like here it moved down, and then we sort of flip or move it up here. So 1 over x to the negative 3 would be like positive x cubed over 1. Right? So if it's in the denominator there, it moves up. If it's in the numerator, it moves down. Okay, and then the final kind of situation, I guess, that could come up would be like, let's say we have 1/2 to the minus 4 on the outside of the fraction like this. So here it was in the numerator, here it was in the denominator, here it's on the outside. Here you just flip it. So flip this over and make it positive. Okay, so here I'm going to flip the whole fraction. So it looks a little bit different than the other two examples. But that's sort of what it means is flip. Do the reciprocal. Okay, so this just ends up being then 2 to the 4th or 16, I think is what that comes out to be. Okay, so if it's on the outside of a fraction, just flip it and make it positive. Right, and generally with negative exponents, you don't want to leave an expression with a negative exponent. You want to, move it up to the numerator here, or move it down to the denominator, or flip it. You don't leave your expressions with negative exponents. Okay, so here's some examples that would be interesting for you to try. These can be really pretty tricky. Okay, these are all negative exponents, and we don't want to leave them with them. So I'd encourage you to pause the video here and try this before moving on. Okay, so hopefully you got a chance to try these, right? So looking at this first one, I always kind of write it over 1. And what happens here is I'm going to move down the negative exponent, move it down to the denominator. Okay, and based on what we talked about earlier, this negative 3, if there's no parentheses, applies only to the x. Okay, so the 7 actually stays up in the numerator, and the x cubed moves down to the denominator and becomes positive. Okay, so that one cleaned up like that. This one is sort of the reverse, where, again, the negative 3 is only for the x, so that's going to move up, and then everything else sort of stays put. So you have x cubed here, and then the 7 is down there because it's not affected by that negative 3 exponent. Okay, next one, the whole thing is affected because there's a parentheses. So I'm going to flip that whole thing and put a 1 on top. Okay, and once we flip it, now it's a positive exponent. That's how we interpret a negative exponent. And then from there, this part we really kind of haven't got to too much yet, but you have a 3x and a 3x in the bottom. So that would become like 9x squared. 3 times 3 and x times x. Okay, and then last one again is kind of the reverse. This is now going to move up. So we still have y up top, but then we have a 3x to the positive 2 power, and all that's left in the denominator is just 1, which really we don't even have to write anymore. And then this top part again, the 3x squared is like 9x squared. So this will be like a 9x squared times the y. And then again, like a denominator of 1. So I'm not even going to write it there. Okay, a couple other sample ones for you to try. Pause the video, give it a shot. Okay, so the key here is the 0. So this is like the negative part is separate from the 3. Okay, so the 3 to the 0 is going to be 1, right? From what we talked about before, anything to the 0 power is 1. So here we end up with -1 times 1, or just -1. Okay, and that's different than this, where the whole thing is affected by the 0, so this just comes out as 1. And you can use a calculator here to help you if you're not sure, but the whole thing is to the 0, so the whole thing just becomes a 1. Okay, last one is just a flip, right? When it's on the outside, flip everything. So you end up with y squared over x4, and then to the positive power. And then again, this gets into some stuff we haven't really done yet, but if you want to clean this up from here, I think of this as this little 2 means we have 2 parentheses, so I'm going to write it twice. Okay, and then from here, if you multiply the numerators, this is the next rule we're going to get into in a second here, but if you do the numerator, you do y squared times y squared, you actually add the exponents there, that becomes y to the 4th, and then x to the 4th times x to the 4th becomes x to the 8th. You actually end up adding them, and we're going to do that rule here in a second. Okay. So yeah, this one actually is our rule next. So, okay, so this is the final exponent rule today, which is multiplying with the same base. And the part that is confusing, I guess, is that kids would think this would maybe be like 9 to the 9th or something, but it's actually not. And so, like, I'm going to try to explain it with the m's over here first, actually. So, like, if we think of this in expanded form, m squared means m times m. And then m to the 4th is m times m times m times m. And so if you look, we have 6 total m's. Okay, so this becomes m to the 6th. So oftentimes I think kids will write, because they see this multiply, they'll think it's m to the 8th. But what you actually do is add the exponents here. Okay, so if these bases are the same, you keep the base and add the exponent. So in this example, we have 3 times 3 times 3 times 3 times 3. Multiplied with 3 times 3 times 3 times 3. This is 3 to the 5th. That's 3 to the 4th. So you keep the 3. It's not a 9. You keep the 3, and then you add the exponent. So it ends up being 3 to the 9th. Okay, so here's kind of a wild example with that. But if you're unsure, the rule is, again, you just keep the base and add the exponents. And if you're not sure, I do this expanded form. Okay, so pause the video and give this guy a shot here. Okay, so basically I'm going to do 5 times the 3 to get 15, and then add these exponents. So it's 4 plus 9 plus 1. That's an x to the 1st. So we have 15 and then x to the 14th power. And again, if you expanded that all out, you'd have 4 x's here, 9 here, and 1 more. So it's x to the 14th. So this is 15 x to the 14th. Okay, one more crazy one here, maybe 1 or 2 more. Pause the video, give it a shot. Okay, so my first thought on this one is, because of the negative exponent, I'm going to move that down. Okay, so I'm going to have y squared on the bottom. And then up top, we have x squared times x to the 1st. So x squared times x to the 1st is x cubed, along with the 12. So we end up with 12x cubed over y squared. All right, one more for you to try here. Pause the video, give it a shot. Okay, so we're going to divide these 4 and 2. These aren't exponents. Those are regular numbers. So we just divide them to get 2, or 2 over 1. Okay, and then the negative exponents, I'm going to move them up. Okay, so up top, we already had an x times a y cubed. And then up top, now we have a positive x to the 5th once we move it, and a positive y cubed. And our denominator just has 1, that's it. So I'm going to not even write it anymore because we don't even have it. And now we just have a 2 and add these exponents. So x to the 1st, x to the 5th is x to the 6th. Y cubed and y cubed, add them together so you get a y to the 6th. So this one cleans up to be 2 x to the 6, y to the 6. Okay, thanks for watching.